kahit naman sa it's easy to adapt to VHDL once you have a good foundation of Verilog. We also have I had a discussion on the uh, initial natin, yung pinaka parang history po ni HDL language, starting with the invention of the transistor, or not the transistor, but the integrated circuit. Okay? Okay? Starting with the invention of the integrated circuit up to the point na na-develop separately si Verilog and si VHDL. Now, the final part of the discussion actually focused on the discussion of the different abstraction levels. Okay, from the highest, which is the system level abstraction, to the lowest, which is the machine level, sorry, the material level abstraction. Kasi we need a knowledge of this kasi nabanggit natin that HDL or HDLs in general can function in many of these abstraction levels. Parang si circuit lang naman sa kasi material level ang hindi kaya ng mga HDLs natin. Okay? Parang if you're going to use you need to use a different software to be able to use that circuit level and material level abstraction. Now, for today's discussion, ang focus natin, ang pinakagagawin natin is we will be looking at the procedure or the process of doing digital design. So, ano nga ba yung pinagdadaan ng steps or process ng isang hardware designer when he or she is creating an integrated circuit? So we'll be looking at in two versions. So we will have what we call the classical version, and then we will look into the modern digital design flow. The main difference between the two is the use of HDLs and some automated CAD tools. Okay? Now, define pa rin natin yung luma kasi what we call the classical digital design flow kasi we will only be having an appreciation of the value of HDL once we are able to learn or understand how they do it without HDL. Right? So let me just go on ahead and share our presentation. By the way, as always, please make sure that we are what do you call this? Paying attention, no? As we will be having a short Kahoot activity, as always, no? Later at the end of the discussion. And then we will be having a fourth essay activity pertaining to this discussion. Okay. So, can someone confirm na lumabas na po si presentation natin?
Yes, sir.
Thank you for that information. This is Introduction to HDL, Lesson 4. So, the main topic actually natin is what we call the modern digital design flow. Pero sabi ko nga, we will be looking first at the classical digital flow. So, let's talk about digital design in general. Okay? When a hardware engineer or a hardware designer designs digital circuits, okay, kung complex si system na pinapa-design, it has to be broken down first into smaller subsystems. Okay? Then each subsystem kung na-simplify na siya, no? Kasi maaaring yung subsystem medyo complex pa din. Kailangan i-divide pa ulit. Okay? Into simpler subsystems. It all depends on the functions. Kung yung system or subsystem multiple function pa din siya, then you can still divide it into separate subsystems pa. Once you reach a point that a subsystem only has one specific function, then that means it's already at its simplest form. And that all the time, that you'll be creating a design for that. So mangyayari, once you'll be creating multiple designs for multiple subsystems, and once you are done, you interconnect them to one another to create the main system itself. Okay? And that design flow is not different. So yung steps na dinadaanan ay hindi po naiiba. Nasa classical digital design flow ka man or nasa modern digital design flow. So yun pa rin yung 7 steps na pinagdadaanan. Ang difference lang that separates the two, as mentioned, the modern digital design flow incorporates HDLs and automated CAD tools. And the classical digital design flow is done manually. So we will be looking at these 7 steps in general. Ano ba yung ginagawa sa mga yan? Starting with the classical digital design flow. Okay. And then of course, we will be giving out an example, a real life example, para mas maintindihan natin, or we should be able to understand ano nga ba yung ginagawa sa part na yon or sa step na yon. Okay? So the first one, okay, let's say you are working for a company that designs digital ICs. Okay? So ano yung mga usual, Intel, Texas Instruments, to name a few. Napakarami pang iba. I don't know how many exist in the Philippines. Dati Intel was part of that before it actually transferred its headquarters to Vietnam. I don't know if Texas Instruments is still in Baguio, but there might be outsourced. May mga companies found in the US or Europe or other parts of Asia or the world for that matter na outsource dito, no, yung ibang steps. So it is entirely possible that once you become a computer engineering professional, that you might be having a career into hardware design. So paano nga ba nag-uumpisa yung process once you are a hardware designer? So it starts with specifications. So it may be individual, but usually it's a part of a team na ibibigay sa team ninyo or sa iyo yung ipapagawa. Paano ba siya binibigay? Usually it's in a set of specifications. System level abstraction yung ibibigay sa inyo. No, sasabihan kayo na I need a digital system, an IC, a microprocessor, a chip, whatever, that does the following. At dapat, bukod sa ganyan ginagawa, dapat ganito kabilis, ganito yung power consumption, no, so on and so forth. So may bibigay siyang constraints. Okay? Pero usual would be timing and power requirements or power consumption. Okay? So, sasabihin sa atin, no, in this example, na pwede nyo gawin, no, even if you're students, you'll be asked to design a digital circuit that would detect a prime number. Medyo may error lang to. This is supposed to be 0 to 7. No? A prime number between 0 to 7. So, may papasok na input that represents 0 to 7, then your IC should be able to detect that the input that was given is a prime number or not. Aside from the overall function, ibinigay din kung gaano dapat kabilis or yung maximum number or maximum amount of the delay. In this case, 200 milliseconds. So parating may constraints yan. Ito na yung pinaka-simple delay. But in most cases, delay and power consumption. Siyempre, marami pang iba. But those two are the most common. Once you have the specification, okay, ang first thing na gagawin mo or ng team mo is create a high-level schematic diagram or a block diagram and an appropriate truth table based on the specification or the function. Si block diagram, okay, would just be a box. You've seen this already, most probably, in electronics or in other stuff. It would just be a box, and then it would show us the inputs and outputs. So ganun lang din ang gagawin mo. The primary reason for doing this is we have to determine ilang input literals or output literals ang kailangan mo to be able to achieve dimension, specs, or specification. Dito tatlo, kasi we can actually go about it in two ways. Either meron kang 8 inputs representing 0 to 7. Okay? So, yung unang input represents 0, 1, up to the last one which represents 7. Then may isa kang output that would tell if the input is a prime number or not. So, parang ang gagawin is that para mapili natin is 1, maglalagay tayo ng input na 1 or high level doon sa pangalawang input. Saan ba't ang gulo? Number 1, but pangalawa. Remember, we started with 0. So, ang una would be 0, pangalawa is 1, pangatlo is 2, up to the point, ang pangwalo is 7. Okay, so tayo magtataka, masanay na tayo that in IT, we always start the count at 0. Anyway, so pwede yun, no? Tapos sa output, mag-high siya or mag-high signal ang output niya if the output is or if the input is a prime number. Then ang output would be 0 if it's not a prime number. The problem with that design is that may mga may parang problem siya with invalid inputs. Kasi ang assumption doon, dapat isa lang sa 0 to 7 ang mag-high level, the rest should be low level. Kaya lang, there is a possibility, due to some errors, na maaring more than one of the inputs would get a level of high. So, anong magiging output nun? So, that would be a problem. Okay? So, and if you're going to implement that, regardless of that invalid input, having more inputs would mean a more complex system. Lesser inputs that you can do the same function, the better, as it would give you a lesser complicated system. Remember, in digital circuits, the less complex, the better. As long as you are still able to give out the same function. Okay? So the approach done here, instead of using 8 inputs, you just use 3. So the 3 would represent binary numbers representing 0 to 7 depending on the combination. Of course, because we are already in our 3rd week or 4th week already, the assumption is nakapag what do you call this? You were already able to describe or you were already able to discuss binary numbers, binary to decimal, or some other subject, perhaps. So in this case, so yun na nga, 0, 0, 0 would be 0, 1, 1, 1 would be 7. Then you create a truth table that would show the outputs based on the input. So in this case, kapag prime number, magwa 1 si output or mag-high si output. Kapag hindi siya prime number, it would be 0. Okay? So that would include 2, 3, 5, and 7 sa prime numbers. Ang medyo alanganin lang ako would be 1. Ang pagkakaalam ko kasi 1 is a 1 is a prime number. Kasi definition ng prime number is that a prime number is a number that is only divisible by 1 and the number itself. Or sa iba, a prime number is a number that only has 2 prime factors, 1 and the number itself. So I have to do a bit of information gathering kung si 1 nga ay pero alam ko talaga prime si 1. Si 0, yes, hindi yan prime. It's neither composite nor prime. Okay. So technically, ang hindi natin prime numbers would be 0, 4, and 6. Okay. In any case, hindi naman yun ang point natin. Ang point natin is we should build a truth table. Yung lesson 1 natin, nabanggit ko na that in digital design, you actually always start talaga with a truth table. You convert it into a simplified Boolean expression. Then from Boolean expression, you convert it into a logic diagram. At yun yung gagawin natin sa next step, which is synthesis. Okay? So this will be the part na aalamin na natin ano nga bang gates ang kailangan natin at ano bang interconnection. Kaya lang, bago tayo mapunta sa logic diagram, kasi we cannot really convert truth table directly to logic diagram. It has to go through Boolean expression, then logic diagram. So, syempre, we must ensure that the logic diagram, the Boolean expression is in the simplest form. Yun yung pinag-aralan din natin at the latter part of lesson 1, in which we mentioned that it should either be using algebraic minimization or K-mapping. And when we mentioned already, K-mapping is better as it is more straightforward. Sa HDL, yun din naman ang ginagawa niyang method, no? Or yun yung in-incorporate niya for some reason. Okay? So, we will just need to do K-mapping. Ito yung process ng K-map ng truth table. Then it would lead into a Boolean expression. Then the Boolean expression, you convert it into the logic diagram. Because the Boolean expression is already simplified. The logic diagram would also be simplified as well. In this case, we need, in order to implement the function stated in the specification, we would need 1 inverter, 2 AND gates, at isang OR gate. The next step is what we call technology mapping. So in the technology mapping, we already have the logic gates. We just need to transfer them, or to rather select a logic family that would be best suited for our purpose or application or function. So the most basic kasi, or the basic family na pwede natin gamitin for logic gate is the 74HC logic family. Okay? So yun yung pinaka basic na pwede natin gamitin. Kung hindi naman tayo masyadong maigpit sa speed or sa delay and plus the power consumption. Okay? Now, another thing that is done to technology mapping, okay, na ginagawa din usually in digital design, is that we actually convert the gates into either NAND gate or NOR gate. If you can remember again from the first lesson, I don't know if I mentioned it to the class. NAND gates and NOR gates are actually called universal gates. Bakit siya tinatawag na universal gate? Kasi with a NAND gate or a NOR gate, you can actually create any logic gates. Okay, NAND gate lang ang gamit mo, bunch of NAND gates, you can create any gates you want, even ng may NOR gate. Now, the reason, so what kung pwede mong gamitin si NAND gate? Can't we just leave it at the initial logic diagram design? No? May inverter, dalawang AND gates ang OR gate. Using NAND gates or NOR gate implementation has several advantages. Una, if we actually implement it as is, you will be needing 3 different kinds of integrated circuits. Isang inverter, dalawang AND gate, isang OR gate. So, tatlong IC yon. Ang isang IC ng AND gate, 4 na AND gate ang laman. Ganun din si OR gate, no? 4 na OR gate. Kasi inverter, 6, kung di ako nagkakamali, ang laman sa isang IC. Pero tatlong magkakaibang IC ang kailangan mo. But when we convert it into NAND gate implementation, you will only need 1 IC type, yung NAND gate. Sakto, 4 din ang laman ng NAND gate na IC. 4 lang din ang kailangan mo NAND gate, so swak lang sa isang IC. So you'll be buying 1 IC instead of 2, or instead of 3. Now, just a word of caution, if you notice, para lang pinalitan yung gates natin, no? Parang ito lang siya na ini-swap out into NAND gates. Hindi po ganun kasimple ang NAND gate and NOR gate implementation. May sinusunod siyang process. I don't know if it would be part of your discussion in logic circuits. May sinusunod siyang process in order to achieve the lahat NAND gates or lahat NOR gates. Okay. I'm assuming nagkataon lang na nung ginamit si NAND gate implementation, nagkataon lang na mukhang pinalitan lang yung mga gates ng NAND gate. But it's not as easy as that. Okay, hopefully maliwanag tayo doon. Okay, nonetheless, yun yung unang sinasabi kong advantage, no? Lesser hardware. Second, kapag ginawa na to in material level, sa last step, sa fabrication kasi, gagawa ka na ng IC nung system mo, no, na pinagawa sa'yo. Na-design mo na yan, so on and so forth. Pag NAND gate kasi, or NOR gate lang ang gamit mo, you'll only be needing 1 design ng gate. Hindi ka nagkailangan ng gate ng AND gate or gate inverter. Isang gate lang ang kailangan mo. At napakadaling i-build, i-connect, i-interconnect, no? Yung mga gates mo. Kasi remember, the gates are made up of circuits, then the circuits are converted into its material abstraction. Dahil pare-parehas NAND gate ang gamit mo, yung gagamitin mong system, parang isang block lang ang gagamitin. You just copy-paste, put it there, then you interconnect. Parang ganun siya. Madali siyang ilagay. No, parang, think of it like a programming code. Na meron kang recurring na code na paulit-ulit, no, na medyo may babaguhin ka lang ng konti or something like that. You have to hard code. So you just have to copy-paste, change the variables, parang ganun lang ang gagawin mo. But because you're going to use the same block of code, no, with just a few changes. So, mas madali siyang i-implement. Okay? So, that is the reason for NAND gate or NOR gate implementation. Once you're done with technology mapping, you now go into the place and route. Sa place and route, pinaplano mo yung interconnection ng inputs and outputs sa wires. Okay? And this is used to be able to minimize the interconnections or the length of wires connecting one from the other. Okay? So gagawin mo siya, then you would be able to estimate later, no, yung delays natin. So the shorter the wires that you'll be using, the better. Okay? So ito yung itsura ng IC natin. As mentioned, you'll only be using one IC. 4 na gates ang laman. And then you'll just be interconnecting the inputs and outputs to one another based on the logic diagram. Okay? Kung 3 IC ang ginamit mo, tatalon-talon ka pa sa iba't ibang IC. Tapos yung ibang gates hindi mo magagamit. Katulad sa AND gate, 2 lang magagamit mo. Sa OR gate, 4 ang laman, 1 lang magagamit mo. Sa inverter, 6 na inverter ang laman, 1 inverter lang magagamit mo. And you'll be using longer lengths of wires to interconnect them, as opposed to only having one IC. After doing place and route, you'll be doing verification. So sa verification, dito mo na i-check kung yung constraints or limitations na binigay sa'yo sa specification process ay nasunod mo o hindi. So that would mean yung delays and power consumption and other constraints na maaaring ibinigay sa'yo. Sa specification natin, ang binigay was delay. So how do we compute for delay? Total delay from input ABC to the output PN is composed of 2 main parts. The gate delay, okay? So gate delay is the delay in the gate, no? That sounds very simplistic, but that's how we can explain it. So may gate tayo, pag nagpasok kasi tayo ng input, may lalabas na output yan. Ideally, it should be instantaneous, but there would always be a finite amount of time na magbabago si output based on the inputs. Okay? And kung naka-chain, kung dugtong-dugtong yung ating mga logic gates, each would actually contribute its own delay. Na for example, pag dumaan sa A, ilang NAND gates ang dadaanin niya? 3. So it would experience 3 beses na delay. So the longer the chain of the gates, the higher the possible ano natin, no? Possible ayun. Guys, kanina pa ako nawala.
Opo.
Anong part nung ano ako nawala? Kasi I didn't notice na until later. Can someone give me a clue? Anong part yung last na narinig nyo?
Possible, sir.
Kaya nga, ano yung part na, pinaka-last part na narinig natin before I went out?
Sa delay, sir.
Sa delay. Okay. Kala ko sa functional design pa lang, nawala na ako eh. Okay. So, kawawala-wala ko lang kahit paano. Okay. Sige. Dali share ko lang ulit. Tinapansin ko kaagad. Kundi kanina pa pala ako nagsasalita na walang ano. Sa moment lang, guys. Wala. Ayan. So going back into the delay. So we have the gate delays. Na nandun yung delays ng gate natin, as mentioned. And the longer the stream or yung cascading ng gates natin, the larger the total delay ng gate. So again, paano ba natin nako-compute ang gate delay? At paano na natin nalalaman yung delay bawat gate? So it is found in the data sheet of our system. Okay, so yung data sheet natin, bawat IC na gagamitin natin, nakalagay dyan yung power consumption niya per gate and also its gate delay. At dahil isang type ng gate lang ginamit natin, it's easy to actually compute the gate delays. The second delay that would contribute to the total delay would be what we call the anyway, na-trace ko na kung bakit siya nagkakaproblema. Sandali. Kasi sumilip ako sa MS Teams natin habang naka-display si Sway. So, dapat di ako babalik. Ayan. Dito lang ako. Ayan. So yun. So ang next na delay natin would be the wire delay. Remember nung sinabi ko sa place and route, we want to minimize the length of the wire. Kasi the longer the length of the wire, the higher the delay or the wire delay natin. Okay? So, as much as possible, we want to make sure you will use the shortest wires possible without sacrificing function. So ito nako-compute din siya. We just assume that the electrons or the flow of current would flow almost similar to the speed of light. Then we will have the length of the wire. Okay? Then distance na kailangan natin. So distance would be kasi ang speed would be distance over time. So time would be distance over speed. Okay, so length of the total wire divided by the speed of light, which is 3 exponent 8, yung approximate value. Then we'll have the total wire delay. Then i-add lang natin yung total wire delay with the gate delay, we would have the total delay ng system. So in this instance, kinompute 150 nanoseconds. So pasok sa delay natin. Okay, pasok siya dun sa ang naman natin malayo, 200 milliseconds. Ito 150 nanoseconds lang. So pasok na pasok tayo dun sa delay constraints. Kung kasama si power consumption dito, isa rin siya sa mga tinitignan, tinitignan na factors kung ma-meet natin yung specifications natin. Okay? So power consumption is also found in the datasheet. Fortunately for us, in the example, hindi naman siya requirement. So hindi na natin siya kailangan computein. But under normal circumstance, yung dalawa, timing delay and power consumption are the most common delays na kinocompute, aside from others. Once we are able to find the delays, it's time to implement it into hardware. Tetestingin na natin. Dito pa lang tayo magte-testing physically kung gumagana yung dinesign natin. Okay, so we will be using yung NAND gate natin together with the wires as interconnections. Okay. Then siguro gagawin natin, maglalagay tayo ng LED sa output para makita natin kung iilaw 1 pag nakapatay 0. Ngayon, there are two possible scenarios here. Gumana siya, ang gagawin mo dyan, tetestingin mo lahat ng possible inputs dito. Okay? Then, check mo kung ganito yung lalabas sa output. So, kailangan, kung paano yung output sa actual part sa implementation, ganun din siya lalabas. And then, yung appropriate delay is within the constraints. That's the best scenario. Worst case scenario, hindi. Mali yung lalabas na output. Now, here's the tricky part with the classical digital design flow. Kapag nagka-problema sa output, it could be sa pagkakakabit mo. That's possible, di ba? Mali ka ng kabit ng wire, mali ka ng ano, may problema sa hardware, may problema sa breadboard, sa wires, so on and so forth. But it could also be a problem sa verification, problem with the place and route, meaning tama naman yung kabit mo, pero mali ka pala ng planning. No, hindi mo nasunod yun dito, pwede yun. O kaya mali ka ng technology mapping, nagkamali ka ng non-gate implementation o NOR gate implementation. Maaari kang nagkamali sa K-map. Pwede yun, nagkamali ka ng K-map, pag mali ang K-map, mali ito. Or mali ka mismo ng truth table. So it could actually be, or it is possible, worst case scenario, you're wrong at ang mali nasa functional design. Kasi you were, in the classical design, in a significant number of cases, you will only be able to verify the correctness of your design sa implementation part. Tapos malalaman mo ang mali sa functional design. So you have to go way back to step 2 and then do all the steps again. Kasi once you're mistaken or you made a mistake in the functional design, all other steps would be wrong. Synthesis would be wrong, technology mapping would be wrong, so on and so forth. Okay? And that is the problem with the classical digital design flow, which we are trying to correct, or it is being corrected by the use of HDL. So when we incorporate HDL, we now have what we call the modern digital design flow. So how would HDL help us in preventing that worst case scenario, quote unquote, na minention ko kanina? HDL allows you to simulate in certain parts or certain steps that would allow you to verify that step before going to the next step. Puro step na lang yung narinig. Ibig sabihin, it means that by using HDL, you can already verify the correctness of the functional design by using HDL before you go to the next step na synthesis. Sinisigurado, or by using simulation, it ensures us that before we pass it to the next step, this is already correct at our level. Kung incorrect yan, aayusin ulit natin until we get, or we have a correct output using the simulation. That would mean in the synthesis, we'll already ensure the functional design is correct. Synthesis, we'll do a synthesis. We do simulation. You get the drill. If it's incorrect, we redo the synthesis. If it's correct, we go to technology mapping. So we would actually be able to get into verification and implementation. Okay. Na sigurado tayo na tama yung previous steps natin. So yung worst case scenario natin, hindi mangyayari. Worst case scenario lang natin, mali yung verification or mali yung implementation natin. Okay? So tingnan natin, sa 7 steps natin na incorporate siya sa 4. So sa functional design. So sa functional design, we will have, sa functional design kasi natin, gagawa tayo ng K-map, ng block diagram, then truth table. So dito, we'll still create the truth table, pero we will be using the truth table and incorporate it using HDL. Then kapag na-convert na natin si functional design natin into HDL, behavioral description, or algorithmic abstraction level, pwede nating simulate kung tama ba yung truth table natin or block diagram. Yun yung kagandahan niyan. Pag na-verify na natin tama, papasa na natin sa next step, sa synthesis. So, it could either be manual yung synthesis, gagawa tayo ng sarili nating logic gates, then ita-transform natin to HDL, or we could use yung binanggit natin sa lesson 3 na automated synthesis. From truth table, logic diagram. Pwede rin yun. In any case, kung ano man ang lumabas sa ating logic diagram, we will be simulating it. And then we will be able to check if it's correct or not. Then eventually, pag tama siya, or kung mali, ganun lang ulit, pag tama, technology mapping na. Technology mapping, gate delays naman dyan. We've already mentioned gate delays already. Okay? So, pwede kasi nating lagay sa simulation yung value ng gate delay. So, sa technology mapping, gate delay muna yung inilalagay natin. We simulate it, and then we check if the total delay hindi dumalampas sa specification ng delay natin. Kasi kung lalampas yan, sa gate delay pa lang, we have to redo some of the things. Okay, so yun lang siguro medyo problem natin. We will be redoing technology mapping, so on and so forth. We'll be using a different IC technology. Okay, may mga IC technology kasi na mas mahal, pero mas mabilis. May mga ganon. So we'll be using that para hindi magpas yung gate delay. So once we are able to meet the necessary requirements for the gate delay, we go to the next step, place and route. So wire delays naman ang i-simulate natin dito. Okay na si gate delay eh. I-input lang natin si computed nating wire delay, then we will simulate, and then we will check if it's within specification. By the way, it's not also delays, but would also include power consumption sa technology mapping. Okay? So, ang wires din naman, kumakain din naman ng power yan, pero kung maiksi lang naman yan, it's not really a problem unless you're creating a motherboard or a very complex embedded system. Gagawa ka ng PCB as a module or something like that. Hindi natin masyadong problema yung power consumption ng wires. It would be usually the individual components themselves. Okay? Once we are able to simulate and ensure place and route, then we go into verification and fabrication. By the way, I forgot to mention fabrication. In both classical and modern digital design. In the fabrication part, ito na mismo yung gagawin na yung IC ng system mo. Kasi may IC na kanina, ito, prototype pa lang to check and test the function. Once you already done with this, gagawa ka talaga ng IC mo that would have the same function pero hindi ganyan kadami paa. Ilang paa lang. Eh di ba? Yun ang silbi ng block diagram natin. So yung paa, 4, 3 input, 1 output. Tapos dadagdagan mo ng 2 paa. 1 paa para sa ground, sa negative part, then 1 para sa positive part, sa VCC. So gagawa ka ng IC na 6 ang paa. Okay? Parang ganon. Then material level abstraction na yun eh. Then bubuuin na siya sa IC factory or IC manufacturing facility. Okay? So yun po, that's it. That's the end of our discussion for today. I'll be checking your attendance muna, and then I'll be sharing po muna yung sa Kahoot natin. Sandali. So pumasok muna kayo doon while I'm checking your attendance. Alam niyo na naman ang gagawin dito. Again, apelido lang ang gamitin. Well, pwede rin naman pangalan. Wag lang pangalan lang. It should be last name. If you want to put in your first name, okay. Kung ayaw, okay lang rin. Pero kung may kaapelido kayo dito, you have to put your first name kasi hindi ko kayo madidistinguish from one for the other. So pasok lang kayo dyan while I'm checking your attendance. I'm expecting 35 participants sa ating for 501P. So pasok lang po while I'm checking your attendance. Okay, I'm done with your attendance. Hindi pa po kayo nakakapasok sa ano? Hindi po ba nasi-share? Sandali ah. Is there a problem with the ano? Sandali. Ayan. Dito na po ba yung sa Kahoot? Can someone respond? Nagka-problem ba kanina? Bakit hindi nakasali? Ayan na. Okay. Baka na-delay lang. Okay, dalawa na lang. May hindi pa ba nakikita yung apelido nila?
Ako po, sir. Hindi ko pa po
Okay. Kamusta yung sa ano? Nakapasok na ba dyan sa loob? Hindi pa. Nag-loading pa din.
Okay na po, sir.
Okay na yan. Ibig sabihin, nandito na yan. Okay. So, hintayin lang natin lumabas just to be sure. So, isa na lang naman yun, no? Ayun na. Ikaw ba yan? Darong? Ayun na. So, ayun na. Nakapasok na siya. So, let's begin. As always, each question is 20 seconds each. Fastest finger wins. Good luck. The first question, in this step, the initial design using HDL is created, okay, using HDL behavioral description. So yung questions natin would focus on the steps, okay? So in this particular step, we do the initial design using HDL behavioral description. So dahil HDL behavioral description to, it would be sa modern digital design flow. So it is the functional design. So not specifications. Let's take a look. Ayan. We have Alarcon, Gumiran, Fortaleza, Legarde, and San Gabriel. Maliliit lang ang difference. So, lalo na si Alarcon, Gumiran, gabuhok lang ang diferensya sa pag-enter ng answer. Next question. What's in which step that we do gate level description using HDL? In the simulation, we use it to check if it matches the output or functional design. So we do gate level description using HDL. And in the simulation, we use it to check if it matches the output of the functional design. So most of you got the correct answer. It is synthesis.
Sir,
Yes.
loading daw po si Borromeo po.
Sige, bigyan ko na lang siya alternative link. Okay. Later. Okay lang yan, Borromeo. Mag-comment ka na lang later sa essay ano natin para mabigyan kita ng link. So next question. So creating gate level connection of the design using KMap. Okay, creating gate level connection or schematics of the design using K-mapping. Anong step kaya yun? Yan, it is synthesis. Let's take a look. Ayan na, number 1 na natin would be Fortaleza. Alarcon is number 2, Legarde and San Gabriel, amangat din to 3 and 4 respectively. De Leon is the highest climber, up 5 places. Question 4. This states the desired behavior of the design. So in which step that the desired behavior is stated? So the correct answer is specifications. Most of you got the correct answer. Let's see. Ayan na. Umangat na si Legarde and San Gabriel to 2 and 3. Nako, may 5 players that actually made a mistake, no? 3 straight na tama, biglang nagkamali. So combo breaker. Let's go to the last question para makita natin yung podium. In this step, the wiring delays can be used to estimate whether the final design meets the timing and power consumption requirements. So the correct answer is verification. Let's look at the podium. So for bronze, we have Alavanzas. Congratulations. Silver, we have Alarcon. And gold, with a 6-point lead, we have San Gabriel. Congratulations, San Gabriel, Alarcon, and Alavanzas. Number 4 and 5, we have Legarde and Gumiran. Okay, congratulations po. Medyo sa isang question lang naman tayo nagka-problem, no? In any case, that's it, no, for today. Bigyan ko na lang ng si Borromeo pala, no, ng link niya, sandali lang. Para sigurado makapag siya. Ano yun? Okay, as always, we will be having our essay question. Makikita nyo sa ating makikita sa Google Classroom. Okay. And then you'll have up until before midnight tonight to answer it. Okay. So Borromeo to lalagay ko sa chat. Paggamit na lang yan. Si Borromeo lang asahan kong gagamit yan. Kung di po tayo makakatapos dun sa essay, magsabi lang po to the chat or to messenger or sa text. Okay lang naman sa akin. At tandaan natin kapag di po nakapagpaalam, hindi po natin ginigradean yung late na quiz, hindi po natin pinagbibigyan sa quiz, late na essay assignment, no? So on and so forth. Okay? So, syempre, mga absent din today na hindi nakapagpaalam would also not be allowed to answer the essay questions. Hindi ko ginigradean yun. Okay? So, fair naman tayo sa lahat. May listahan naman tayo, nag-attendance naman tayo parate. Okay? Anyway, thank you very much, guys. And we'll just talk again on our next synchronous class for our 5th lesson. So, next week, makakadalawang lesson ulit tayo. Then, most probably, we'll have our quiz 2. And then, eventually, yung ating midterm exam. Parang naka-6 na weeks na yata tayo. Hindi, pang-5 pa lang yata kung hindi ako nagkakamali next week. Then, pang-6 pa yung susunod. Okay? Anyway, thank you very much, guys. Have a great weekend and stay safe as always. Bye-bye.